Hello students, I hope you are all doing well. Welcome to another video by QuickStudy. This video covers the topic of the structure of the atoms from the GCSE Chemistry syllabus. So let us get started. So let us begin by understanding what an atom is. An atom is the smallest particle of an element. Each atom is made up of subatomic particles called protons, neutrons, and electrons. A molecule consists of two or more atoms that are chemically bonded together, such as by covalent bonds. The nucleus of the atom contains protons and neutrons. The nucleus is positively charged due to the positively charged protons. The electrons orbit around the nucleus of the atom, contributing very little to the overall mass of the atom, but creating a cloud of negative charge around the atom. The electrostatic attraction between the positively charged nucleus and the negatively charged electrons orbiting around it is what holds an atom together. In an atom, the total number of protons and the total number of electrons are equal, for which an atom is a neutral. The electrons move around the nucleus in different energy levels. These energy levels are called electron shells. In the first electron shells, 2 electrons can stay. The second electron shell can hold up to 8 electrons, while the third electron shell can only hold up to 8 electrons as well. Now, let us explore the subatomic particles of the atom. What is the atomic number or the proton number? The number of protons in the atom's nucleus is called the atomic number or the proton number. Each of the 118 different elements in the periodic table has a unique atomic number or proton number. For example, if an atom has 8 protons in the nucleus, that atom must be an oxygen atom. What is a mass number? The total number of protons and neutrons in the nucleus of the atom is called the mass number of the atom. The mass number is calculated by adding the total number of protons with the total number of neutrons. For any particular atom, the information can be shown like this. The chemical symbol of the atom is used to show the atom, while on the top left-hand side, the mass number is written, while on the bottom left-hand side of the atomic symbol, the atomic number is written. So what is the electronic number? The electron number is the number of electrons in an atom. The subatomic particles are so small that it is not practical to measure their charges and their masses using conventional units such as grams or coulombs. Therefore, to measure their masses and charges, we compare them, and so these are called relative atomic masses and relative atomic charges. These are not the actual charges and masses, but instead are charges and masses of the particles relative to each other. The table below shows the symbols and the masses and the relative charges of the subatomic particles. So now let us move on to isotopes. What are isotopes? Isotopes are atoms of the same element which have the same atomic number but different mass numbers. This means the isotopes of an atom have the same number of protons but different number of neutrons. For example, there are three kinds of isotopes, three kinds of atoms of carbon called carbon-12, carbon-13, and carbon-14. All three isotopes of carbon have the same proton number, which is 6, but they have different neutron number for which the mass number varies. Varying number of neutrons in the nucleus makes no difference whatsoever to their chemical reactions. The chemical properties are controlled by the number and the arrangement of the electrons in the atoms, and that is identical for all isotopes in an atom. The relative atomic mass of each element is calculated from the mass number and the relative abundances of all the different isotopes of a particular element. It is the average mass of an atom taking into account the amount of each isotope present in a naturally occurring sample of the element. For an atom which has 2 isotopes, the formula is shown below. Now, let us solve some problems regarding relative atomic mass. The question says, a naturally occurring sample of an element of element boron contains 20% of boron with an atomic mass 10 and 80% of an isotope of boron with an atomic mass of 11. Calculate the relative atomic mass. To solve this problem, let us imagine there are 100 atoms of boron. We can work out that 20% of them, that is 20 of the atoms, will have a mass of 10 and 80 of them will have a mass of 11. Now we will plug in the values in the equations as follows to get an answer of 10.8. Therefore, the relative atomic mass of boron is 10.8. With this, we have come towards the end of this video. So let us have a quick review of what we learned so far. We learned about an atom and the subatomic particles that make up an atom, which are protons, neutrons, and electrons. We also learned about the isotopes of an element and how to calculate the relative atomic masses of an element considering the isotopes. Thank you for watching this video. If you liked this video, do consider subscribing to our channel as we post regularly on different topics and subjects regarding the GCSE syllabus to help you ace your exams. For more information on our one-on-one online tutoring services, do visit our website www.quickstudy.uk. Thank you.